Welcome back to the Cave of Science. I'm going to do a little bit of a review on the high pressure, low pressure. So let's take a look at this. So let's take a look at the low pressure here. Low pressure is really, when you think about it, is rising air. The air rises, and as it rises, it can cool, and once it can cool, it can condense and form clouds. So one of the characteristics is rising air and cloud formation, or cloudy skies, or precipitation. And then the other one, you also have, because of the Coriolis effect, you have this counterclockwise rotation in a low pressure. Now, high pressure, we have just the opposite. High pressure is sinking air, so the air is sinking towards the surface of the earth, and if the air is sinking, it's pretty tough for clouds to form. And so typically when you have your nice sunny days, you typically going to have a high pressure. So as the air sinks, it inhibits the formation of clouds, and you have a rotation that is clockwise. And this rotation around a high, again, high pressure will always flow into low pressure. And so when you think of the characteristics, low pressure, rising air, cloud formation, if you will, precipitation, and counterclockwise rotation. When you have a high pressure, the air is sinking, no cloud formation, and you have a rotation that is clockwise. So remember that when you start talking about a high and low pressure areas. Alright, the next one I want to look at is a weather map, and there's a few things we can check in on this one. First of all, the major thing whenever you look at any weather map is the whole idea of the mid-latitude wave. And a mid-latitude wave, I'm going to circle it right here, is the major weather-producing feature in the continental United States. And a mid-latitude wave is a combination of a low pressure, which we have right here, with a cold front attached to low pressure and a warm front. And those are found very, very common when you find these in the midsection, eastern two-thirds of the United States. So this is a mid-latitude wave, and it's the major weather producer in the continental United States. So you get rid of a couple things here. And you may ask, well, where do these air masses come from? The air masses in a mid-latitude wave, one, the warm, moist air, is it? Oops, I got it too thick. I gotta get this a little thinner. Is a maritime tropical. And this maritime tropical forms in the Gulf of Mexico, and these will have a tendency to flow to the north. The cold air, which is a continental polar, well, it's cold and dry, and these will form in Canada, and they will flow down south, and if conditions are right, these can meet up, and you're actually going to get a counterclockwise rotation. And typically when you think about a mid-latitude wave, this also is where you're going to have your precipitation. And if you look right, along the cold front and this whole area here of a mid-latitude wave, you can see there's quite a bit of precipitation going on here. So you have the warm tropical air, maritime tropical, coming out of the Gulf of Mexico, working its way north, and a Canadian polar coming out of Canada, which is going to be dry and cold, working its way in, actually going to the south. And you can see as they hook up in this particular feature, they will form a mid-latitude wave. The other thing we talked about, and let me get rid of some of this on here, is the this is the direction that these mid-latitude waves will travel, or most weather features will travel in the continental United States. Most weather features in the continental United States will move to the northeast. And the reason they move to the northeast is because the vast majority of the United States is what is in the prevailing southwesterlies. So the wind is coming out of the southwest and it's pushing all these systems to the northeast. Now, if you were down here in this area, you get down to about 30 degrees north latitude. In this area here, you get into the northeast trades. And as we talked about in class, this is why many of the hurricanes get pushed across the Atlantic Ocean. But for the United States, most of it, we're in the prevailing southwesterlies, and everything gets pushed to the northeast. Now the other feature which drives weather systems across the I want to get a little bit bigger here, across the continental United States, is the jet stream. And the jet stream is that upper level river of wind which also helps to direct features across the across the world, but mostly we're going to look at the continental United States. And if you recall, most low pressures are in a trough and high pressures are going to be what is called the ridge. So I'm going to see if I can draw one here. So we have a low pressure here, so you would expect to see a trough. And then the high pressures over here and probably over in this area are going to be what is called the ridge. So the low pressure is going to be in the trough, and the high pressures are going to be what is referred to as a ridge. Now remember, this wind moves from west to east, so as it's moving in this direction from west to east, it is actually spinning the air in a counterclockwise rotation. As it is in a ridge, the air is actually getting spun in a clockwise rotation, and therefore that also helps to enhance the rotation of a high pressure and a low pressure. So in a trough, you're going to find low pressures, and when you have the high pressures, you're going to find them in a ridge. All right, let's look at a couple more things here. Yeah, I didn't want to do that. I got to get it bigger again. We talked a little bit about the southeastern part of the United States. You start getting out into this area down here, and this is about 30 degrees north latitude. And 30 degrees north latitude, that is the climatically, that's where your deserts are, because that's a global high pressure system. This map's not going to show up, but the equator's low, and climatically that's where you find your rainforest and your jungles. Now, one more feature on this map is we can see we've got isobars, or lines that connect points of equal pressure. And if we look on here, we can see, you get into the southwest part of the United States, you get into this area out here. Isobars are spread pretty far apart, so you would expect low wind speeds. When we look over here, over the Dakotas right now, it looks like the isobars are closer together, so therefore you would expect higher wind speeds. So this is a little bit of review on the weather map and high and low air pressures, and that's it right now from the Cave of Science.